In the previous lecture, I discussed constellations, bright stars, and planets, things that are easily visible, even from within a bright city. Now let's move on to faint, diffuse phenomena, where you need really dark skies. Such phenomena include the Milky Way, auroras, and the zodiacal lights. And you don't need any special equipment to see these things. Binoculars or a telescope are not needed. Just look at the sky with your naked eye. Here's the Milky Way, a faint, diffuse band of light stretching from horizon to horizon. It consists of many, many faint, distant stars. And to see them, you really have to get away from bright city lights. Here's what happens when you are in a city whose lights are getting brighter and brighter. When the lights are faint, you can see lots of faint stars there, including the bright ones, of course, that you can see even from within a bright city and bright planets. But the faint stars are hard to see unless the sky is really dark. So to illustrate that, let me increase the amount of light pollution in this city. The city is growing. Population is out of control. It's growing and growing and growing. And look at what's happening to the faint stars. They're being washed out by the glow of the city. The bright stars are still visible, but the faint ones are not. And the bright planet, like Jupiter here at the left, is also visible through a telescope, although the contrast decreases somewhat. So bright city lights really hurt. So does bright moonlight. You don't want to look for the Milky Way when there's a really huge full moon out illuminating the whole sky. It just washes these faint things out. Here's an example of two views of the Milky Way taken under bright conditions with a city down here illuminating the sky. You can see some of the faint fuzzy clouds of the Milky Way. But if you move to a much darker location, look at the dramatic change in the amount of faint material that you can see. It's just astonishing. This is actually not that bad a view, considering it's near a city. You can see at least some of the Milky Way. But look how much more you can see when you get away from city lights and when you wait until the moon has set. You can see so much more, and there's all this structure in the Milky Way. Look at that. We'll discuss all that in a few minutes. How does the Milky Way form in the sky? What causes this band of light? Well, really, as I said, it's the countless stars that you can see through our galaxy. Our galaxy is a collection of billions of stars. It's shaped something like this galaxy, a spiral galaxy. If we could view ours from the outside, it would look something like this, not in detail, but in overall structure. It's a disk, perhaps 100,000 light years across, but only about 1,000 light years thick. So it's a very thin structure, kind of like a CD or a DVD. And in the middle, it's got kind of a bulgy region like this. So a schematic of what it looks like is shown here. Viewed edge on, the disk is this thin plane, kind of like a CD. The bulgy region is in the middle, the very nucleus is right in the center. Our sun is about 2/3 of the way out from the center to the edge, and there's no well-defined edge, so this is a bit of an arbitrary number, 2/3. But you know, when you take a photograph of a galaxy, depending on how long you expose, you can make the edge go farther out or closer in. But for most typical photographs that are taken of galaxies, if you were to put our sun at the same location as it is in our galaxy, it would be something like 2/3 of the way out. And when you look along the plane of our galaxy, the Milky Way galaxy, you see a multitude of stars in any direction along the plane. That's the Milky Way. If you look perpendicular to the plane, you see relatively few stars because the whole plane is only about 1,000 light years thick, much thinner than the extent of the disk in these directions here. So you see very few stars, or comparatively few, when you look outside the plane. I like to show these kinds of things with simple models that anyone can make at home. You don't need complicated equipment to visualize the universe in many cases. You can just put together a couple of paper plates and a tennis ball, and this is representative of the flat disk of our galaxy and the bulgy middle. Here our sun is about 2/3 of the way out. I've drawn it on the surface here, but it's actually inside. It's somewhere near the middle of this disk. And when you look along through the plane of this galaxy, you see myriad stars, whereas when you look basically perpendicular or at angles that are nearly perpendicular to the plane, you see comparatively few stars. So the origin of the Milky Way is the view through the plane of our disk-shaped galaxy. Okay, that's all it is. All right, well, it's really fun to look at the Milky Way from a dark location because you can see fantastic structure. Here are relatively dense clouds of gas and dust mixed with stars. In other places, the stars are relatively isolated. You don't have the clouds of gas and dust enveloping them. But in other places, the clouds of gas and dust are so thick that they actually block our view of the more distant stars. So it's not that there's a dearth of stars in these locations of the Milky Way. Rather, it's that there's dust and gas blocking our line of sight in those directions, kind of like gas and dust in our own Earth's atmosphere blocks the sunlight when the sun is setting. You know, the sun appears fainter and redder, and you know. Here's a wide-angle view of the Milky Way where you can see its structure very slightly. This is looking toward the direction of the center of our galaxy, toward that bulgy part, so it looks thicker. And there's the rest of the plane, and you can see these splotches of dust blocking our view in certain directions. This area here is very nice because it looks like a cross. This, in fact, is the Southern Cross. It's a rather small constellation, Crux, and it looks remarkably like a cross, and it has a very dark region next to it called the coal sack. This region has a heavy concentration of dust that blocks our view of the more distant stars. To the east of the Southern Cross, which is very easily recognized if you're in the southern hemisphere of the Earth, is the nearest star to our own sun, Alpha Centauri. Actually, Alpha Centauri is a double star system, and the star that's closest to us right now is the companion, the faint companion of the bright star, and it's called Proxima Centauri. It's proximate to us, so it's a little bit closer than the bright one, but both of them are about 4.2 light years away, so we're seeing them as they were about 4 years ago. So there's Alpha Centauri and Beta Centauri in the constellation Centaurus. If you take a wider angle view of this region in the southern sky, you have Alpha and Beta Centauri, you have the Southern Cross and the Coal Sack, and to the west of the Southern Cross is a diffuse nebula, a glowing cloud of gas and dust. And in that nebula is one of the most fantastic stars known. We'll study it later. Here's a Hubble Space Telescope photograph of it, but it's a very massive erupting star. It's perhaps 150 times the mass of our sun, and it's going through an incredible period of instability where it's gurgling off its outer atmosphere in outflows like this. It's just a fantastic star which we think will truly explode within the next few hundreds of thousands or millions of years, something like that. Give or take, a few days or years. Anyway, going further west from the Southern Cross and this nebula with the amazing star in it, by the way, the nebula is called the Eta Carina Nebula. So going further west, you reach another grouping of stars called the False Cross. You can see it looks like a cross. Join those two stars and those two, and that looks like a cross. But it's not the true Southern Cross. The true Southern Cross is this one. This one is a little bit bigger and a little bit more irregularly shaped. It precedes the Southern Cross in the sky because it's to the west of the Southern Cross, and stars rise in the east and set in the west. So a constellation or an asterism that is to the west of another one precedes it in the sky. You see it earlier in the night than the other one. As I mentioned in the previous lecture, sometimes planets can mess up the apparent shapes of constellations. Here is Scorpius. There are the pinchers, and there's the body, and the tail, and the stinger. Here's Antares, the heart of the scorpion, a red supergiant star. And this thing here doesn't belong. Well, it belongs that night. It's the planet Jupiter, but a few months later, it'll be in a completely different spot. So sometimes you can get confused by these apparently extra stars and constellations. Here's a nice image of Scorpius. It beautifully shows the complex structure of the Milky Way in this region of the sky. Indeed, to the east of Scorpius is Sagittarius, and the center of our galaxy is toward the direction of the constellation Sagittarius. But I love this part of the sky. Look at the structure of the Milky Way in this part of the sky. It is just fantastic. An enhanced view of the main stars of the Scorpion is shown here, and now you can see the constellation Scorpius a little bit more clearly perhaps than you could in this previous picture where the stars are shown in their true relative brightnesses. The center of our galaxy is toward the constellation Sagittarius and Scorpius, this region here. But the whole plane of the Milky Way extends to the east and to the west of that. And when you're in the Earth's southern hemisphere, that part of the Milky Way is high in the sky. It's low in the sky when viewed from the northern hemisphere because Scorpius and Sagittarius are relatively southern constellations. So they're pretty low in the sky when you're in the northern hemisphere, and these clouds of gas are a bit harder to discern. But when you're in the southern hemisphere, it's magnificent because you can see this band of light stretching across the sky, and the brightest parts are overhead at certain times of the year. And you see the central part of our galaxy overhead. It is a truly marvelous view. You feel like you're a real part of the galaxy when you're in a dark sky with no city lights, no moonlight, and just these stars. And here's the Milky Way going from horizon to horizon. You feel truly immersed in it in a way that's difficult for me to describe. I first had this experience when I was in the southern hemisphere at Las Campanas Observatory in the Chilean Andes Mountains. And there it's really dark. You're hundreds of kilometers from any major city, and it was really, really dark. And I just felt like so much a part of our universe, of the galaxy at that moment. I was really looking forward to my first trip to Las Campanas Observatory to gather data for my PhD thesis. At that time, I was single, and my graduate student colleagues said, "Oh, you'll love this observatory. There's a woman behind every tree at Las Campanas Observatory." So I waited, I went there with bated breath, and to my disappointment, I found that there are no trees for hundreds of kilometers in the Chilean Andes at the edge of the Atacama Desert. You can see this is the typical site. There are no trees. So sure, there's a woman behind every tree, but oh well, there are no trees. But fortunately, I had this splendor of the Milky Way to look at instead. Well, the central part of our galaxy is in the constellation Sagittarius, and it's marked by the green square here. Later on, I'll tell you that there's an incredible black hole in the middle of our Milky Way galaxy in the direction of the constellation Sagittarius. It has 4 million times the mass of our Sun. And it will turn out that massive black holes are a common characteristic of the central parts of galaxies like our Milky Way. If you are in the southern hemisphere, you get the additional advantage that you can see 2 satellite galaxies of our Milky Way galaxy. So there's the plane of the Milky Way, the band of light that we call the Milky Way. Here are these 2 patches of light that appear to be distinct from the Milky Way, and those are galaxies. They are small galaxies that orbit around our Milky Way. They're called the Magellanic Clouds, named after Ferdinand Magellan, who wasn't by any means the first to see them, but I guess that shows the influence of Europe at that time because they're named after him and his voyages. There's the Large Magellanic Cloud, and there's the Small Magellanic Cloud. The large one is about 170,000 light years away. The small one is about 210,000 light years away, and they orbit our galaxy. Here's a close-up of the Large Magellanic Cloud. It's a beautiful structure with a fantastic nebula here called the Tarantula Nebula, a glowing cloud of gas where new stars have recently formed and are still forming before our very eyes. There's the Small Magellanic Cloud. It too has some wonderful regions of star formation. Sometimes, distinct from the Milky Way, another faint diffuse phenomenon can be seen. That's called the zodiacal light. Here's an example of it. You really have to be in a dark sky to see it, but it's a sort of a conical, diffuse band of light seen to the west shortly after the end of evening twilight, and to the east shortly before the beginning of morning twilight. You don't want twilight to have quite begun because it tends to swamp out this faint glow. This is known as the zodiacal light. It appears in the plane of the sky through which the sun moves. The sun moves through certain constellations that I'll discuss in a little while. They're